I got a warning, so I will not cover any US product or any US company issue. And I'm not here to give a demonstration, but we will go over the technology. A little bit agenda for my speech today. Something about the motivation, why we got these electronic passports. What does the government think about electronic passports? Some basics, and probably you heard about this cloning thing. Who of you guys knows about cloning passports? Only a few, so I will cover this. And how to use a clone passport to attack the systems, like the reader and the inspection database behind. We will cover some stupidity on the basic access control and the extended access control. The extended access control seems to be the silver bullet against cloning and doing everything nasty with it. And some unexpected risks at the enrollment. So all of you guys know what is the motivation to get biometric into the passports and for the visas. This is actually the recovered visa they found at Ground Zero. So I don't know if he's still on the watch list, but they found some evidence that he is involved. So that was the main motivation, to raise the security for the US borders and to improve the border security by using biometric solutions. There was this initiative. So the government after 9/11 got a dream, and the dream is telling, so we have to divide high risk travelers from medium risk travelers and low risk travelers. If one of you guys come the first time to the States, they have to create a file on you, put your fingerprints in and a picture of you. So you are at this moment a medium risk travelers. At the moment you are crossing the border about 100 times a year and nothing happens and you are not on the watch list, you are a low risk traveler. And if you are coming from a suspected country or you have a common name like Mohammed Atta or something like this, you end up on a watch list and be investigated as a high-risk travelers. And the government dreams about this automatic multi-biometric entry gates. So the normal passenger just waving his electronic passport, putting his fingerprint on it, or looking with his iris scan into a camera, and magically the door opens and he is in. While for the medium and high-risk travelers, the door stays closed and they have to check an inspection officer, and the officer is making investigations. And by the way, it saves a huge amount of money on personnel, especially for European entries. They want just to shut down the amount of inspectors needed per passenger. So first, the government is going to ask, who can help us by this project? And they start asking the security print notes and all the security stuff over the time. And these are general and global print shops. They know how to produce micro ink. They know how to make counterfeit safe banknotes. They know how to use special holographs and putting it in and making special drawing on your passport cover and gluing it together so it cannot be split anymore and stuff like that. But are they known for IT security know-how? Do they have a history on IT security, on cryptography? No. So they have never done actually an IT security project. So what's coming out is these security print shops are going to ask the smart card industry. And now we got a problem. The smart card industry is focused on selling their products and advocates multi-purpose use. So some of the original ideas for the electronic passport, you would have a multi-purpose use. We will get the identical design for the national ID cards. These cards can be used for electronic banking, for e-government, so you don't need to go to your DMV, you just put in your ID card into a reader on your PC, and you can cryptographically sign electronic signatures and don't go in person anymore. Even in Estonia, they made this year, they have something like multi-purpose smart card based ID card. They made this option so that the citizens are allowed to vote using their ID card and a normal PC, and use it for email encryption and ID and travel document as passport, and of course for electronic payment. Sounds it nice? One card that fits all. And let's have a look of the design goal. So they want to use cryptography and PKI. The best thing is we put all biometrics that's possible into this card. If you got more biometric, you got a higher safe level. And of course it will be 100% secure and improve the facilitation, something like minimize time spent on legitimate travelers, once again segmenting low and high risk travelers, and minimize immigration time, are all wonderful. And then they came up with a design approach from the ICAO. The ICAO was setting up a standards group, and all this group was staffed with printing experts. So they know how to make secure passports, but even no IT security expertise. And pretty soon they discovered, we need some experts on the crypto. We need to do crypto. At the first design approach, there was no cryptography. So they thought, we just put in the files into a storage and that's it. And the very first ICAO design doesn't care about cryptography. And this scares even some experts at the governmental level, and they told me, no, we cannot use it. We have to use cryptography. Otherwise it will be a nightmare. So, but no one knows anything about implementation. And the whole thing now was driven by RFID manufacturers. And of course no one looked at risks and design goals. You all know this, keep it stupid and simple. But they unfortunately don't know it. And by the way, the industry got a new standard for biometric encoding. We got new encoding. We have to put all this together into this passport. And the next problem they found out was they got a problem with patents. Typically, if you store biometric data, you are looking only for some points of interest, like from your fingerprint, and generate via a trapdoor algorithm a type of hash, and this hash ends up in a database. So they don't put actually a full picture of a fingerprint into a database. They're just putting in the hash, so it makes things easy to compare. It's always easy to compare about a hash and look for collision, but it's highly difficult to compare images, even if they are put from different angles and stuff like that. So, and as well, the ICAO decided to store the facial image of the passport holder, like as a JPEG or JPEG 2000, and they decided doing the same with the fingerprint. The problem was the most hash algorithm was patented by one or other company, and if they want to use it on a global basis, they have to do a decision for one hash algorithm. Unfortunately, all these hash algorithms don't fit with the national fingerprint databases. So every country is operating their own fingerprint database and using a slightly different hash algorithm. And up to this time, it was, for instance, not possible to compare a fingerprint from a US citizen using a hash from the FBI database with the European Europol database, because they got completely different values. So they decided, just make a picture of the fingerprint and put it into the passport. And we got here some compromises, but we all know compromises don't work with security at all. So let's have a small excursus how the e-passport looks today, and how the e-passport is implemented from the German point of view. By the way, all these pictures are public domain. I put the reference behind, so Actually, as far as I know, I can use it for this talk. So, the e-passport is most likely called MRTD. This stands for Machine Readable Travel Document and is known as electronic passport. The specification was done by these experts groups from the ICAO, and the enrollment was planned on a global basis. This is one actual picture from the e-passport from Germany. They decided to embed the RFID tag into the cover and not into the data page. Normally you have one of this plastic covered page where, for instance, Great Britain or Australia putting in the RFID tag. And they decided we don't need a shield. The passport could be readable even if the passport cover is closed. By the way, this is one of the decisions why the Germans can microwave the RFID chips in the e-passport and the British can't. No one sees the marks from the burning if the RFID tag is embedded into the cover. If you do it with a British passport, you're most likely melting some plastic on this page. There's an alternative method of storing data. So right now it's possible to store biometric data or hashes as a 2D barcode under the facial image. And we have this line. It's called MRZ, that stands for Machine Readable Zone. And this will play a second role for authentication and cryptography if we look deeper at the electronic passport. So let's look for the data layout of the electronic passport. They invented a huge branch of new cool names. We have to deal with the LDS, that stands for Logical Data Structure. And the data is stored in DGs. DGs, data groups. Some of the data groups are mandatory, others are optional. Some of these data groups are slightly controversially discussed. For instance, the British wants to have an iris image inside the data group. The German decided not to use iris images. You can look for the actual health status if you do the immigration, and you can check if someone was consuming drugs or alcohol. It's not a problem in GB, but probably in Germany. So, and it's not illegal in Germany to travel drunken as soon as you are not driving the car. And so they decided not to use the iris image in Germany. We have a special file that's called EFSOD. SOD stands for Security Object Data. And this is a file that holds the cryptographic signatures. And we have the EFCOM, you can compare to a directory that lists the existing data groups. All data is stored in BER encoding like ASN1, but it's not ASN1 that's important. And the data group 2 up to 4 uses CBEFF for encoding. This is a common biometric file format. It's specified in ISO 19785. We have in Germany some unique security features. So normally if you activate an RFID chip, you got a unique ID. This unique ID is fixed for each RFID transponder or chip. And this unique ID is needed for anti-collision. Unfortunately, with this unique ID, you are trackable and traceable without knowing. So it's just the installed reader at the gate, and they know who you are and that you are holding a passport and stuff like that. So they decided to prevent tracking of the owner of the passport without access control by generating random serial numbers for these RFID chips. So actually they produced a special tag, and the special ISO 14443 tag can jump after it got started or awaked by the radio field, and use a random number generator and use this random number as unique ID. By the way, you can use this random number generator just to put in any ID you like. So another way to cloning RFID chips. And the problem is ICAO MRTD specification don't require a unique serial number. So, by the way, some countries will generate random ID and random serial numbers, some countries don't. So, for instance, some guys from Belgium and some guys from Australia are highly trackable and traceable without a shield and carrying a device that identifies they exactly. And for the Europeans, or especially for the Germans and the British, it's slightly a bit more complicated to track them, but it's still possible. But for the first phase, you get this unique ID. And they put in a method, it's called passive identification. And this method is mandatory for all passports. And this method is a proof that the passport files are signed by the issuing country. So if you get a passport, each issuing country is operating their own CA, and this CA is signing the hashes of the data of your passport. And with this private key signed, the public key can prove at the border control or at the entry if this data are manipulated or original. That's all in theory. And the document signer key is retrieved from the public key directory that's operated by the ICAO and useful only if country root CA is known. So actually this public key is right now, as far as we know, hard-coded in the RFID readers. They read the passport at the inspection. This is a slide showing how the signed data works. So we have all these different data groups. Then hashes generated over each of these data groups. And over a list of all these hashes, they are generating a type of master hash. And this hash over the hashes of the data group is signed by the country CA and stored at the EF slot. By the way, who of you guys thinks putting a password on the monitor is a secure and safe way to hide it? Isn't it a nice idea? No one can read my passport because we put in a cryptography. So they have this method, it's called basic access control. And actually they're using the credentials that are printed on top of your passport. So to grant access to the data after the inspection system are authorized, the authorization is done through the machine readable zone. So what they're actually doing is they are generating over the document ID and your 6 digits date of birth and the document expiry date and triple dash key and using it for authentication against the passport to read your data that are stored on the passport. And that's exactly what they're doing to protect the privacy of the passport holder. Even some European passports, for instance Belgium, don't have basic access control. They can be just read by walking through. And so what do we have with the basic access control? So the access key is printed on top of the passport. And what the politics is always denying, it's illegal to make copies of banknotes, it's illegal to make copies of passports. Who of you guys experienced that his driver's license or passport was put on a Xerox machine because you want to rent a ski or you want to check in a hotel and it's highly crowded and we got some up and they're just making a Xerox and you don't know what happened with this document. Anyway, all this data needed for accessing the machine readable zone is as well stored in many private databases like airlines, banks and so on, credit history, and no one knows what's happened to this database if there's identity theft or if someone breaks into the database and retrieves all this data. And as soon as this data are known, there's no protection for your facial image, for your biometric template. You can just tracked, traced and read from behind. So, and you don't need to do a full read of the passport. It takes sometimes up to 40 seconds. But if the data are known, you can just start with a basic access control handshake and you are still traceable. So the random unique ID is simple worthless if you have access to the data you need for generating this access key, or to generate the first phase of communication to your electronic passport. And access to the content of the logical data structure, data group 1 and 2 is possible. Even access to the SOD is possible, so you can try to run a brute force attack against the company signing CA. After my last talk last year at Black Hat, I mentioned this, I make a small demonstration, and they are telling us, oh, yes, but you know, basic access control was yesterday. Today, and we will have in the future, extended access control. This will take care of all these needs, and this is a highly cryptographic thing, and you don't have to worry about your privacy anymore. So what's the idea of extended access control? The extended access control should prevent the unauthorized access to biometric data. Unfortunately, it's not international standard, so each country decides what data they want to share with what exact country, and it's implemented by the individual issuers, and only share with those countries that are allowed access. So in theory, for instance, if Germany wants to share the fingerprints and the biometric data with their citizens between the states, they're setting up a IT project for exchanging certificates and algorithms and putting in additional software into the readers. And they are pointing out that access is only possible with certificates from issuing countries. So if at the point of entry at a port or at an airport, the inspector wants to read your fingerprint, by the way, it's a GIF image, he needs to get a certificate from the issuing country. And they are telling all the time, this certificate is only valid a really small amount of time. And only at this small time slot, you are able to read the biometric data from the passport. Unfortunately, just imagine, you're a train conductor and you have to check if the tickets are valid and if the passengers are on the right train and if the ticket are for the right date and time. But you don't have a clock. So how do you check it? How do you check if the ticket is valid? And we got the same problem because they forget to implement a clock inside the machine readable travel document. So you got a small amount of time, you got a certificate for unlocking the passport and for reading the biometric data, but the MRTD does not have any reliable and secure time information. And without this time information, once the CV is captured, all MRTDs which has been read using a CV certificate, that's the name of this unlocking certificate, issued earlier, could be accessed without any problems. And the MRTD could not verify the validity of the timestamp from the CV certificate because he don't have a time signal, he don't have a time date, so he cannot check. But you know, the politics are telling you we are safe, we have only issued certificates for a small amount of time. Even they are going to save the last time of access, and if the next CV certificate has an earlier date, it's going to reject. So if someone is using a false CV certificate with an issue date far out in the future, the pass is rejecting all earlier CV certificates. So one possible attack could be just faking GPS or just faking GPS time signal for the data center. They are issuing in Germany the CV certificates and trying to put the clock of the servers up to 2080. And if they're not using Windows or Unix machines and don't have this problem with this 32-bit clock override and GR2000 problem, most probably they can issuing certificates from the year 2080 and deactivate all issued passports with extended access control. Because after they fix the time, all the passports get deactivated. The next problem is a road regime could misuse the CV certificate to obtain fingerprints from the passport holder. You know, the fingerprints are stored as a GIF image, so you can make fake fingerprints. And with this fake fingerprints, it's possible to produce false evidence. The next glorious idea was we're using X509 certificates, but it's not possible to revoke certificates from the MRTD. So CRL is effective not existing. And everyone can verify it seems to be secure, but it's not possible to revoke a certificate. So, why do we clone passports last year? We got a huge media attention on this, and they are telling us cloning a passport is just normal behavior, and there's nothing dangerous on it, and you don't have to care about this because it's all cryptographically signed. So, the normal tags inside the passports are actually read-only, and data could only be retrieved from a issued passport. And one idea is just retrieve the data from an issued passport, just read it, then you have to microwave your original RFID chip from the state, and now the clone tag behaves like an official e-passport. And that's where the fun part starts, but what the industry is not understanding. I had long phone conversations with head of research and development from an e-passport reader company, and he is just not believing, oh, if something is not put in the right way, we are triggering an exception and everything will be fine. But you can put in an exploit and extend your official passport and putting in some malware inside the MRTD. And the nice thing about this exploits is it could attack inspection systems as well, backends or databases behind this. And you can imagine what's inside this database behind your passport inspection system. And I guess they are using some standard off-the-shelf components like Oracle or DB2. So what's happened if someone is using a drop database or an altered table or just changing some data inside? Now let's have a closer look to the inspection system. First of all, there came this, all inspection systems should be evaluated. What does it mean? No one is telling us. What does it mean to evaluate an inspection system? Right now they're using off-the-shelf PCs. And off-the-shelf PCs are far too complex to be formally validated for correctness. Otherwise, we don't have to deal with malware, with viruses, with crashing operating system and stuff like that. Then they decided to use JPEG and JPEG 2000. We all know JPEG 2000 is a very complicated format. You can easily produce huge images, allocate a huge amount of memory. It's easy to exploit. I put in some CVE numbers. We found about JPEG 2000 exploits. And we got these nice tools like Metasploit and other toolkits that make it really easy to put in some shellcode in your passport. Isn't it nice? And that's actually a vendor's design of an e-passport inspection system. You know, it was designed for Windows XP, even not for Vista. So, and actually we found no security improvement to the software. The stack is still executable. And imagine what's happened if you just ask an officer, oh, did you mind putting in this USB stick into your inspection system and make it double click on this program? You think they are going to do it? But they are putting your passport on a reader. And where's the difference? It's just memory, 72 kilobyte memory that's got read into his machine and executed. And that's the nice thing. They just don't look for the procedure. So actually, the LDS is passed part by part, and after the whole structure from the passport is read into the reader, into the inspection system, it can be validated just after this. So they have to build all these hashes inside the machine, and then after they have decoded this highly complex tree of ASN1 beer encoding, after they got through all these different stages and highly complex processing units, and I know what I'm talking about. We have implemented this e-passport design, and it was damn hell of coding because they don't care about standards. So after all the thing is decoded and passed and not exploited, and all the structures are happy, they can validate. So first they read the data, then they pass the structures. After this they have to decode the payload, and finally they can verify the document cryptography. It's something like you go to an ATM, you put in your card, then you get the cash, and after you got the cash, you put in your PIN number. And they are telling you, is it right or not? Cool, isn't it? I would like to have such ATMs. So, and right at this moment, many vendors are happy if they can read the passport from a different vendor. So they have actually the problem to read the passports. And no one has checked for illegal structures, or even for some malware onto it. The next problem we have to deal with are biometric data. So at this moment, data should be reduced to hashes only, but fingerprints are still stored as pictures. So reverse engineering of fingerprints is possible, and this is contrary to any best practice in IT security. Don't give up your credentials, and even don't make them public available. And we got this nice chaos of standard. So all these experts from the ICAO we have to use ASN1. You know how ASN1 works normally? You have a lex, you generate a grammar, you put in your data structures in C, and they are putting in into this, or you make a formal description of the ASN1 data structures, and ASN1 generator is generating a parser for you and an encoder. So you got two pieces of software, and then you put your payload through this encoder. You got the data encoded in ASN1, and afterwards you can put it to the parser. It's like valid XML, and you got it back in your C data structures. But unfortunately, they don't ask a student in the first semester who knows how ASN1 works. They have done it a different way. They make the encoding by hand, and they make as mistake without generating a lex. They're saying, we have to encode this in this specific byte pattern, and the structure is actually not valid ASN1. So it looks like ASN1, it's 90% like ASN1, but you cannot use a formal ASN1 encoder because it's not like ASN1. They just don't understand how such meter formats and encoders are working. The next problem is we have a lot of redundant meter formats for biometric data. They use JPEG images, but they encoded the JPEG image in a different meter format, like the CBEFF Common Biometric File Format. You know why? The industry from the smart card and RFID came up, we designed a cool format, no one is using it, we have to put it into the e-passport. The next problem is, if a signing key got lost, the whole country is doomed. I'm pretty sure sooner or later some of these keys got lost. Not in the US, probably not in Germany, but there are far too many countries outside. We have sometimes problems with the structures in the countries. Sometimes we got a country that converts to a rogue regime. We have sometimes political instability, and in some of these cases it's most likely that a signing key got lost. And then anyone can produce these false passports. And the whole design was made by politicians and not by IT security experts. And of course it's possible to manipulate data. So I went with a short version of this presentation to an ICAO meeting, or to the security document world, and I got a huge amount of very interesting quotes. The first one, trust us. We are the experts. We know what we are doing. The next was a nice quote from one. We removed the standards from the ICAO website. Now we are safe. The next standard is, it's for my own State Department in Germany. So Grunwald was using the primary purpose of the passport. He read it. There's no security risk at all. And the next, I really like this. The RFID chip will be protected by the security features of the printed paper in the passport. Wait a minute. Why do we make this RFID passport? We want to raise the level of counterfeiting passports with biometric data. And normally the RFID chip should increase the security and not needs to be protected by the printed paper of the passport. So, where's the need for an RFID chip? If the chip must be protected by the printed paper, why can't my person protected by the printed paper as well? And we just forget all these RFIDs? I don't know. And the next quote is one of my favorites. Once again, after I gave this presentation at the Security Document World in London, a couple of high-level passport security experts are here. And they are denying there's any problem. And after I gave this, I got that really nice quote. It's right that there are security flaws could harm an IT system, but we have to keep in mind the e-passport is a security document and has nothing to do with IT systems. But it runs on Windows XP. So, isn't it funny? And if they don't change their thinking about IT systems and structures and how to audit these things and where are the risks and pitfalls, I don't know how can they, I have no advice for them. There are experts out. In every country there are IT experts, there are experts on structures, on encoding, but if they don't listen to them, it's not our fault. So, and that was pretty much my update for the last year, what we have done on electronic passports. And we can start the question and answer session. First, that's here. And after I'm finished here, I think I'm moving to the Q&A room for additional question and answers. So, yes. Yeah, the question is why still keeping the RFID on the passport if there are some questionings. And one of the results is they wasted so many taxpayers' money. They just can't tell us, oh, sorry, we are wrong. By the way, we wasted billions of dollars worldwide, but we have to live with them. So I think it's about personalities and reputation of the print shops, and it has nothing to do with IT security and anti-terrorism and counterfeit documents. Yes?
What happens when a manipulated picture gets right? So you put only your passport, that the right face, go to customs, what happens?
I have done some tests with okay, so the question was what happened if a manipulated pictures get through an RFID reader or get through customs. So I've tried this with some manipulated images at a conference. I'm not going to tell what conference this was and not the vendor, but actually one inspection system gets in an infinite loop reading the things and another just crashed. So we got a blue screen. And if you are able to get a blue screen, you are most able to put in exploits. But everyone is welcome to prove. I can't check with any US passports, but if some of you guys have one of these US passports properly, he will be here next year at my position and presenting us the ultimative inspection database take over, world domination inspection owned applet just to apply to an US passport. I can't do it, but I don't know if I inspire some of you guys. Next question. Yes? Actually, they don't know how to do it. They don't ask anyone who knows anything about IT security. So, and they had such huge time pressure, and they want to do it all on their own. So the group from the ICAO was a pretty closed group. And they don't want to get as many external experts in because it was so complicated at that specific level. The industry wants to push in so many different standards and so many different encodings. They just want to keep the group as small as possible to make effective working. So that was my point. And I got a quote from a German passport manufacturer, and he is telling me, oh, I know, we know, the whole thing is junk, the whole standard is junk, but we have to live with it, and we cannot change it anymore. Next question, yes? Can you speak up a little bit? Yes, there are many parallels. One of the problems is every time you want to create a protocol or security protocol by a committee and by compromises and not by public discussion, you end up with such a mess like this ICAO passport. So, my advice would make a RFC of it, put it on the internet, make a public discussion, ask the crypto experts, ask the security experts, and not make a design by committee. Mostly the crowd is just smarter than you are. Next question. Okay. Thank you.